Today we're going to start with diagramming and reviewing some information we already have learned in order to study the I can statement a little more deeply today, which is I can describe and compare pH of substances. So while I get set up to do some sketching, please read the first paragraph at the top of your notes. All right, so I'm going to make a key on the side over here. When I use the color gray, it's going to represent the number of protons. And when I use the color blue, it's going to represent the number of neutrons. And lastly, when I use yellow, it's going to represent electrons. And so we're going to get started by following the directions on your paper. It says draw a detailed diagram of hydrogen atom in the circle on the left. So I'm going to go ahead and get started and draw a big circle here. And that represents a nucleus. So what goes in the nucleus of an atom, right? It'd be protons and neutrons. So how do we figure that out? Well, we know hydrogen has an atomic number of 1. So that means that I'm going to go ahead and fill this chart in down here. We know that because it has an atomic number of 1, it's going to have 1 proton in its nucleus. I'm going to go ahead and draw 1 plus sign there. It's not really a plus sign. Let's go back and fix that. All right, so instead I'm going to say P equals 1. All right. Now, how do I figure out neutrons? I take the atomic mass, which is like 1.0 something something, and I round it to the nearest whole number, which is 1. And then I subtract the atomic number. So that actually is going to give me 0 electrons. So I'm not even going to write in anything for neutrons. I'm going to leave it alone. Now, for the electrons, a normal hydrogen atom would have the same number of protons as electrons because most atoms have a balanced charge, which means a 0 charge. So I'm going to go ahead and write a 1 here, and I'm going to create my line, my dotted line. Anyone remember what this is called? It is called, it's kind of a really bad drawing of one, but it is called an energy level. And I am going to put only 1 electron out there on that energy level. So talking about valence electrons, as you just kind of reviewed earlier at the top of your paper, hydrogen has 1 valence electron. And we know this because its outer energy level, it only has 1 energy level. And so therefore it's the number of electrons in that energy level, and it would be 1. So again, the charge when this atom is alone, it is balanced because it has 1 proton and 1 electron, or 1 positively charged subparticle and 1 negatively charged subparticle. And I just realized that these are messed up on your notes, so you want to definitely change those. Electrons have a negative charge and neutrons have a 0 charge, so please make sure you change the charges there. But moving on, we're going to go ahead and say 0. But we will talk about this last column later, and it's the charge when part of a water molecule. So we'll come back to hydrogen in just a second. Let's move on to oxygen. I'm going to draw another circle representing the nucleus of an oxygen atom. Now, when you look at oxygen on the periodic table, it has the atomic number of 8. So I'm going to go ahead and write an 8 there, and I'm going to say P equals 8 because I know it has 8 protons. Now, to figure out the neutrons, again, I take the atomic mass, which is 16 point something, and it does round to the whole number of 16. So to find the number of neutrons, I take the rounded atomic mass of 16 and subtract the atomic number of 8, and I also will get 8 neutrons. So I am going to go ahead and write in N equals 8. All right, And then I'm going to go ahead and create my first energy level, which I'm going to kind of go along this orange circle here. And we know that it will have 8 electrons because when it is a regular oxygen atom, it will have a 0 charge when it's alone. And so therefore, I'm going to go ahead and draw in my electrons. On the first energy level, I can only have 2 electrons there. So I'm going to put those there. So that means that it does have a second energy level. So I'm going to kind of go out here. And I'm going to put in my other 6 electrons. So 1, 2, 3, 4, 5, 6. So it has 6 electrons in its outermost energy level, but it could have 8. So its valence electrons is 6. So I'm going to go ahead and write that in my chart. However, we need to talk about both of these atoms. They bond well together, and the reason why is hydrogen is, even though it is a nonmetal, it has many metal properties, and that's why it's listed on the left side of the periodic table. And it loves to give away that extra, or its electron, it's one electron, it loves to give it away or share it with other molecules. And then by having pretty much no electrons, it considers itself to be happy or whatever at that point. Yeah, happy. So hydrogen, if we have 2 hydrogens and 1 oxygen, both of those hydrogens kind of give their electron to oxygen, and oxygen is too short of being filled. So when it gets those 2 electrons from hydrogen, it is very happy. So basically in the middle, and this isn't going to be easy to do, so I'll do my best. But what happens is we get 2 hydrogen atoms, and I'm just going to kind of write an H and an H that joins on to an oxygen atom. And in doing that, it kind of has, and I'm just going to use the electrons because the protons and neutrons don't really matter much in this discussion about bonding. So I'm going to draw that 1 electron from hydrogen on that one and the other one over here. And it's so willing, because it acts like a metal sometimes, to give away that 1 electron. And oxygen is so badly wanting to have those electrons that its outer energy level then is filled. So the circle around the oxygen is just showing the outer energy level, and the other 6 electrons, 1, 2, 3, 4, 5, 6, there they are, but 8 really all total because it just stole 2 from both of the hydrogen atoms. So this is how it gets a charge, and I'm going to kind of show you this. So basically, the hydrogen atoms now become positively charged. So this water molecule it has a polarity that's positive on this side because hydrogen just gave away its electrons to the oxygen, and it's slightly negative on this side of the atom because oxygen just gained 2 electrons. And so this causes a water molecule to be polar, which means that it really has a 0 charge. However, one side kind of has a positive charge and the other side has a negative charge. And that will be important for properties that we're going to talk about having to do with water the rest of this unit. So I want you, let's see, so the last part of this is we need to finish filling in our chart. Charge when part of a water molecule, the hydrogen kind of becomes a positively charged side of the water molecule, while the oxygen side, since it stole the electrons, becomes more negatively charged. All right, so we're going to continue now with the presentation and wrap up the notes. I only have about 5 minutes left on this video, so we'll just get as far as we can and we'll wrap up the rest later. All right, so real quick, every liquid is either a pure substance or a mixture. So when we talked about matter the other day, we did a hierarchy diagram and we learned that. And not only would every liquid either be pure or a mixture, but it would also be acidic, basic, or neutral. So most liquids are going to be acidic or basic. However, few are going to be neutral. And acidic, basic, and neutral are the three main descriptors of pH. So a little bit more, we went ahead and broke down a water molecule, but I like the way that it kind of shows how well water molecules join together. So like up here in the top right-hand corner, it shows us that one molecule alone, the hydrogen side is slightly positive charge, and the oxygen side is going to be slightly negative, which means that water likes to cling on to itself. So water molecules are attracted to each other because they opposite charges attract. So the negative oxygen side will attract easily to the positive hydrogen side. And this property of water is called cohesion, and it is a property that we're going to talk about a lot this year because water not only likes to stick to itself, but it also likes to adhere to other things, which is going to come in handy when talking about the water cycle later on. Now, on the next page of your notes, it goes into dissociation. So it's important that you understand that when we use this term, what we're talking about is the ability for a substance to dissolve when placed in water. And this substance could be a pure substance or it could be a compound. Basically, dissociation is a big word for breaks apart. And what happens is if you have a compound that breaks up, then basically you have ions that are floating in the water, and they can easily stick to water molecules because of that the polar sides of a water molecule. So if it is an ion that is positively charged, it will stick to the negatively charged oxygen side of a water molecule. But if it is a negatively charged ion, it will stick to the positive charge side of the water molecule, which is the hydrogen. All right, so if the dissociated dissolved compound releases an H+, which means it's a hydrogen atom that has a positive charge. When it breaks down, it is an acid. And that H+ ion can join with another water molecule to form a new compound, H3O+, and that's called hydronium. You recently read about this in your textbook. So an example of this is hydrochloric acid, which its chemical name or formula is HCl. The H stands for hydrogen and the Cl stands for chlorine. So therefore, when HCl dissociates in water, it breaks apart. And the Cl will be negative because it stole hydrogen's one electron when it bonded together originally. So when they break apart in water, it keeps that extra electron. So Cl would be negative, and the H lost its electron, so that is why it has a positive charge, and we call it a hydrogen ion. Now, if the dissociated compound releases a negative OH, which is called hydroxide ion, when it breaks down, it is a base. And NaOH is an example of this, which is sodium hydroxide, and we're going to talk about that more in the notes. But basically, the Na becomes positive when it breaks apart from the OH in water, and that is because the sodium, the Na, stole it gave away its electron to the oxygen, and the oxygen in the OH, that makes it a negative compound that breaks apart from the sodium atom.